The purpose of this lab procedure is to find the empirical formula of a reaction of zinc metal and iodine by using the masses to relate to the moles in the formula. In part B, we first determined which salt we received and then secondly found the formula for the reaction.
Okay, part A is zinc iodide. We weighed a beaker, approximately 50 to 100 milliliter beaker, added 0.6 grams of zinc and 0.6 grams of solid iodine, and about 5 milliliters of 0.2 molarity acetic acid. The acetic acid is used as a place for the reaction between the zinc and iodine to occur. We then swirled the beaker occasionally and waited for the reaction to complete. This happened when the beaker was clear and colorless. It took us approximately 20 minutes. There was aqueous solution of zinc iodide and acetic acid. We decanted the solution from the unreacted zinc and washed the solid zinc by adding around 3 milliliters of 0.2 molarity acetic acid to the beaker with the solid zinc, then removed 3 times. Then repeated with DI water, dry the remaining zinc and weighed when cooled.
For the calculations of part A, we weighed the mass of iodine, which was 0.6 grams, and then we got the moles of it by dividing it from the molar mass of atomic iodine, which was 126.9 grams per mole, and ended up getting 0.004 moles of iodine. Uh, for the zinc, we measured the mass of the beaker with the dry zinc in it versus the empty beaker and got 1.1 grams of zinc remaining. Then we subtracted the initial zinc, which was 1.1 grams, from the zinc that was remaining, and we got the result of 0.17 grams of zinc that reacted. Then we found out the molarity, the moles of zinc by dividing it from the molar mass of zinc, which was 65.38 grams per mole, and got 0.002 moles of zinc. Then to get the last product, we divide 0.004 moles of iodine from 0.002 moles of zinc and got 2.
Part B. First, we added approximately 4 grams of ammonium hydrate to a pre-weighed crucible. We heated it gently for 20 minutes with the lid slightly open so water vapor could escape. We weighed once cooled, heated again for 5 minutes, then weighed again and got the same weight both times. After we did a series of tests to find which anhydrous salt we were dealing with, no reaction occurred to the test, and we found out we had magnesium sulfate.
First, we subtracted the mass of the crucible with salts last heating minus the mass of the crucible, which gave us 1.33 grams of salt. Next, we subtracted the mass of the hydrate minus the mass of the hydrosalt and got 0.64 grams of hydrate. Next, to find the amount of moles in the moles of water in our equation, we take the mass of water over the molar mass of water to get 0.035 moles of water. Next, we find the moles of anhydrous salt. We take the mass of the anhydrous salt, 0.69, over the molar mass of anhydrous salt, which is 120 grams. And we got 0.005 moles of anhydrous salt.
In conclusion, potential sources of error would include the reaction not fully completing, the zinc not being completely dry, and calculations being off using the beaker and weigh paper. Using this method to find the empirical formula is very straightforward and simple to do by using simple mass percentages and moles and relating them to what we know about compounds and reactions. As the chemists at Purdue have released, finding this can be done in 4 easy steps. First, get the mass of each element by assuming a certain overall mass for the sample. And then, secondly, convert the mass of each element to moles of each element using the atomic masses. Thirdly, find the ratio or moles of each element by dividing the number of moles of each by the smallest number of moles. And then fourthly, use the mole ratio to write the empirical formula.